Welcome to APA's weekly webinar. My name is Billy Zadig, Standards and Codes Administrator for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA website later this afternoon, and a follow-up email will be issued to you as a reference on where to locate the session. Professional Continuing Education and AIA HSW SLUs credits are being offered for today's program. If you are an AIA professional requiring a certificate, please send an email to me, Billy, at BILLIE@APA.org, along with your AIA membership number if you have not done so in the past. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by one of our presenters. At this time, it's my pleasure to turn this over to Sam Schwartz from Energy Management Association to introduce our panel for today. Sam, take it away.
Thank you so much, Billy, and welcome everyone to The Future Isn't What It Used to Be, Occupied Space in the COVID-19 Era. I just want to start things out by saying that this webinar provides a great demonstration of how the affiliated Energy Management Association, AABC Commissioning Group, and the Associated Air Balance Council brings members together to accomplish a shared mission. All three of the engineers on the panel today hold certifications from one or more of these associations, and the perspectives they'll bring you will demonstrate to building owners the value and importance of energy management, commissioning, testing, adjusting, and balancing providers. So without stealing any more time, let me start introducing you to our speakers. Wade Conlon of Hanson Professional Services Incorporated is an ACG certified commissioning authority with over 25 years of commissioning and design engineering experience. Among his many ASHRAE posts, he's the chairman of the ASHRAE Epidemic Task Force Reopening Team and Director at Large for the ASHRAE Board. Eric McEwen of TLC Engineering Solutions is a CXA and EMA energy management professional with over 12 years of experience. Eric facilitates operations and maintenance training for building owners, specializes in control strategy optimization, and has extensive experience in writing commissioning specs, test procedures, and plans. Justin Garner of Engineer Air Balance is an AABC Test and Balance Engineer and CXA. At ASHRAE, he's actively involved in all of the national committees associated with building commissioning. He's also the past chairman of ASHRAE TC 7.7 on testing, adjusting, and balancing, and the current secretary of ASHRAE Guideline 0, the commissioning process. He is also the chairman of ACG Certification Council. James Moore is the co-founder of Brightline Strategies, a research advisory services firm for real estate development, marketing, and management. He leads client engagements and day-to-day company operations. Thank you again, everyone, for joining us. And with that, I'm going to hand it off to Wade to kick us off. Wade?
Thanks, Sam. So let's go ahead and start advancing the slides. So just a couple learning objectives to go over for what we were thinking will be covered in this course. Obviously focusing on COVID-19 and the SARS-CoV-2 virus, but just trying to make sure that we have a different understanding of HVAC systems and how providers are responding to those challenges. So next slide. We just went through the introductions. Each panelist is going to give a little short presentation by each that covers some of their concerns. These are meant to be kept in a 5-minute range. At the end of that, we will dig right into the question and answer session for all the different panelists and discussion from that point. So next slide. So here's our panelists. We can go ahead and skip to the next one. And then the next one, because this will get into what I'm going to cover. So, as Sam noted, I lead the building readiness team, and I'm a voting member of the ASHRAE Epidemic Task Force that formed in late March, early April to try and create a lot of guidance for HVAC systems and building systems with respect to SARS-CoV-2, the virus that creates COVID-19. It's intentionally called Epidemic Task Force, and it was focused to look at 3 different areas. One was the short term, which obviously was COVID-19. 2 was the near term, which was more of the resurgence or the second wave that you've heard about. And then the third is to make sure that a lot of this guidance isn't just left off by the wayside, and that it gets incorporated into either standards or guidelines or technical committee chapters and a lot of that information, so that it allows us to future-proof buildings for the next epidemic. And so that task force was created, and there's a lot of different teams, schools, residential, healthcare, filtration, and others. If you go to the ashraid.org website and onto the COVID-19 resources, you'll find a really great infographic that'll show all the different parts and pieces with links. There's a lot of information up there. But as far as the building readiness team, and it's in the purpose of that is what you've seen here, is to create practical guidance to operate your building depending on which mode you're in. And that differs based on your location. I'm down in Florida. We've been pretty big hotspot here of late. There's other areas in the country that are not. And then it also gets into your climate in terms of different things that you can do. So, but when you're looking at your modes of operation, the way it's broken down is epidemic conditions in place, and you need to figure out where you're at with those. And that's going to be fluid. That will change as you go forward, right? In March, April, May, a lot of it was people being unoccupied or very lowly occupied. And then eventually it does touch on post-epidemic conditions in place. That prior to occupancy really applies even to the, before you go into your building for when they're in place, but it gives a little bit of guidance on how to think about your systems and a lot of the analysis that Justin and Eric are going to touch on that you want to think about for future proofing that building and your other designs. So next slide. And the biggest thing here is it's not done by one individual. No project ever is done by a single individual. And so there's a lot of people that you could or should involve in this process, right? You've got commissioning providers, you've got test and balance people on this, and they're very crucial, right? One of the big things is how much outdoor air am I bringing in? Well, you want a certified test and balance company and agent to do that for you. A couple items on the bottom there, the owner's facility staff and building operations. And usually during the commissioning, retro commissioning, we're involving the owner's facility staff because they know where the tweaks they've made and the different adjustments they've done to the systems and where those skeletons may be hid in terms of trying to make sure that it's operating properly. And they're crucial to that. But in this mode, because we're dealing with how the building is going to operate, you're going to have to get into what kind of occupancy are you going to have, what kind of schedule are you going to get into, and so that building operations side is more from the people in the building as opposed to the HVAC systems. But depending on your building, your scenario, you will find all of these involved in this process. So next slide. And this is an image that I love. It's what are we really battling, right? We're talking about SARS-CoV-2. When you look at that little image on the left, the little gray dot that's exploded out to see the image that a lot of us have seen, that virus that's showing, your 0.06 to 0.1 nanometers, right? That's the virus by itself, and it's a RNA lipid container that's very easy to defeat, but it's invisible to the naked eye. And so the reason this slide shows is it's a progression of different materials, right? And so you hear about PM 2.5 and PM 10 for your outdoor air quality, but the reason the PM 10 is there is that's kind of that visible thing. So when you're driving in your vehicle the right way and the sunlight hits it and you see those little specks of dust that you didn't realize were there, that's PM 10, right? So you can see the relation of this virus on its own compared to that. We do know that the virus is very sticky, and it is clumping together with other particulate when it is in the air. And so it's not just, having to deal with it at that tiny size, but that is what we're dealing with. So next slide. And to touch on one of the things is I get asked a lot is, well, what should I do, right? What's the most important mitigation strategy or engineering control? And it's all particular to to each HVAC system that you're dealing with. And so you can see that on the left-hand side, there's the different methods, right? Ventilation, filtration, air cleaning, temp and humidity control, air distribution effectiveness, right? There are a lot of different methodologies, and depending on what kind of system you have, what's going on in your space, you have to evaluate which ones you would utilize, right? Just so you know, the assumption is that you are meeting the ASHRAE Standard 62 or your code minimum of outside air being delivered to the space. That's a given. And so, but when you look at these different methods, what you're seeing is in the bottom left, it talks about how you can combine these and what kind of effectiveness you can get. And on the right-hand column, you're seeing like, so at a 1 micron particle, a MERV 13 filter is about 85% efficient. If you have UV, that's a single pass in effect kill rate, but ineffectiveness or kill rate of 85%. When you combine those, you're actually in series, and so you're actually getting a much higher performance from those two things combined, right? These aren't always additive. So if I've got displacement ventilation and upper room UV, those don't go hand in hand, because upper room UV is assuming that you're getting a lot of recirculation, or like a DOAS unit and then going to HEPA filtration on my DOAS. Well, aren't we kind of considering the outdoor air is already not infected to a degree? And so are you really picking up any benefit by doing that? So, but those are the different engineering controls that should be applied, and I think Eric's going to touch a bit on, but I believe up next is Justin.
Great, thanks, Wade. I'm going to talk a little bit about something that Wade briefly touched on, but it's the importance of the test and balance firm on your team. You can go ahead and go to the next slide. So a lot of the things that are included in ASHRAE's documentation that are being put out there, and you're going to hear Eric talk about it a little bit more, is strategies for increasing ventilation, potentially increasing filtration effectiveness, things like that. Especially if you're going to be increasing ventilation rates. That's not something that you want to take lightly, especially given the certain areas of the country. I'm in Houston, Texas, kind of like Wade. It's a very humid environment, especially this time of the year. You need to be very careful if you start increasing outside air ventilation rates, because you can very easily overpower the cooling capabilities of your equipment and cause a lot of other really nasty problems. So it's very, very important that you bring in a qualified firm and a qualified team, for that matter, to do that. And so I guess the real question is, what does the test and balance firm do, or what is their value in this team? And so independent firms, there's firms that are contractor associated, and there are some that are independent firms, such as ABC members. They can work directly with the owner, the design team, and the commissioning provider, assuming you have all these folks on your team, or certain members of those folks on your team, and as you should, depending upon the scope, the overall scope of the changes that you're considering. It's interesting to note, ABC member firms provide what we call total system balancing. And in addition to balancing expertise, having the ability to go and take measurements and certify those measurements for outside air capacities, things like that, across the entire range of air, hydronic, and plumbing systems. Total system balancing also encompasses controls. So they can function on your team very effectively with not only your contractor team, your building operations team, maybe your building automation folks, and even your existing building commissioning providers, like Eric's going to talk about here in a moment. So just keep that in mind. But most importantly, the TAB firm is a critical member of the team. They're there to take physical measurements and help the team get good data, so that both the owner and hopefully the design team and even the commissioning professional that's on board can help achieve the goals that are trying to be achieved from a standpoint of increasing ventilation or making the environment safer, if we can do that. And so the key to it is we were having a short conversation about this before we went live. You need someone that's qualified, that has the appropriate training, the appropriate instrumentation, and the appropriate technical capabilities to go and take those measurements without impacting operations, hopefully, and be able to do it in an efficient manner so that the team can make good, solid decisions. Another part that's often overlooked when folks think about testing and balancing is the sensor and control verification that I alluded to a little bit earlier. That oftentimes your controls vendor, your building owner, even your commissioning provider may have the instrumentation that a test and balance firm has. And some keep it up to date calibrated. Some have the expertise and things like that to know when things are going out of calibration or to verify it. But that is a tab firm's requirement. That's in every major national or international standard out there for testing and balancing, is the instrumentation. That's our lifeblood, so to speak, right? We have to have reliable instrumentation. We have to keep it up and verify the calibration regularly. And so to that point, who is better to go and actually take those measurements to verify the sensor calibration than someone who's as rigorous with their instrumentation as the testing and balancing firm? And so I would encourage you to not only use them for airflow measurements, capacities, things like that, but to also have your tab firm involved if you're going in and doing any kind of retro commissioning or things like that to evaluate where your systems are to make some significant changes. They can be an invaluable part of that team to verify the calibration of your points and sensors in your BAS. And then your test and balance firm, as I kind of alluded to before, needs to have direct input to the owner and the design team. In many instances, we see it, and I talk to folks throughout the country, and I know the tab firms sometimes a third or fourth tier sub, and they kind of get pushed to the wayside, maybe underneath the mechanical umbrella. But in this particular instance, what we're talking about here, it's a critical effort, and you really need to have that transparency and the visibility all the way up to the owner and the design team, and have the test and balance firm as one of those first tier members of your team. Go ahead and go to the next slide, please. All right, so we kind of talked about this, but some of the recommended services if you're going to bring in a testing and balancing firm, some of the things that you're going to be considering and that you would want them to work on in their scope would be measuring outside air, exhaust air, ventilation rates, and air change rates in certain spaces. This is very applicable to critical environments, happens every day. But with the onset of this pandemic and the push for increased ventilation rates and things like that, it's bleeding over into spaces that it was typically about thermal comfort. So if you have a typical commercial building, a K through 12 school, a higher institution of higher education, commercial office space, things like that, these types of measurements and analysis are becoming more mainstream now with the onset of this pandemic, and looking into the future on how do we combat these types of scenarios, even hopefully one day when we get past COVID-19. So it's very critical that we start looking at this outside of the critical spaces, not just healthcare, but and critical clean room type environments, and look at it in all spaces. Part of that is obviously measuring the spaces, measuring air change rates, things like that, which your tab firm can provide. The second part is calibration of your airflow monitoring. When a test and balance firm comes in and they take a measurement, that's a snapshot in time. Hopefully they're taking the right snapshot, but it's a snapshot in time. But what you're going to get through BAS trending and overall monitoring of your system is only as good as the instrumentation that's providing it. And so back to some of what I said in the previous slide, you really need to make sure your airflow monitors that measure your ventilation rates are calibrated correctly, and they're operating across the entire range, not just a single point in time, but from full minimum to maximum, whatever those may be, and whatever they may be in the future if you're going to make changes to that. Filtration pressure drop measurements and that effect on your fan systems, especially if you're going to increase your filtration systems, which may put a heavier load on your fan system. The test and balance firm is probably one of the only folks that can help with that. So it's critical that they have the capabilities to go in and measure that and really look at your fan system curves and see how those are going to be adjusted and give that information to the owners, personnel, and the design professionals that may be involved. And then obviously space air change modifications for public and high occupancy areas. This is something that I talked a good bit about it in the first bullet point, but it's invaluable there. You've got to understand the entire scenario. It's not just supply, it's not just outside air, it's the entire ventilation of the system, especially if you start talking about larger areas. You really got to have good data there so that the design team and the owner can make good decisions. And most importantly, I can't stress this enough, Wade's nodding his head here because I think he knows, you have to take these points across the entire operating range. It's not good enough to just walk in and say, hey, let's take measurements today where the system is operating. Well, the system may be operating at 50%, it may be operating at 25%, it may be operating at 100%. It's very important that the test and balance firm and the entire team understands what the system capabilities are across the entire operating range, from minimum to maximum or whatever the future maximum may be, so that everyone can get an accurate picture and make good, sound engineering decisions moving forward. So that's my soapbox for today. Hopefully it's been informative, and I'm going to go ahead and turn it over to Eric McEwen.
Thanks, Justin. So Justin is going to overlap a little bit on the things that I talked. So we're going to kind of piggyback on some of that. So the discussions we're going to have here is kind of what I would consider your first steps in your building. You can go ahead and go to the next slide for me. So the first steps that we're going to say that you need to do in the building is re or retro commissioning. And I use those two terms loosely because re and retro commissioning defined by ACG and ASHRAE are a lot more involved than what we're looking at specifically. It's more of a health and wellness type check of your building to kind of see what's going on. So the first step is to perform an on-site assessment of your existing conditions, looking at physical equipment and BAS. I broke it up into two. And then your second step is to evaluate possible COVID-19 mitigation strategies. I call them mitigation strategies because I think we all know that we cannot completely eliminate this, but we're going to just trying to do the best we can to mitigate it. Some of those strategies include upgrading filters, pre and post occupancy flushes, controlling space humidity, and possibly using some different technologies that are available out there. Next slide, please. So with the on-site assessment, ideally you would definitely want to bring in a TAB contractor on board with you, like Justin said. And some of the things that you want to take a look at is, first and foremost, I believe, is your outside air damper operation. You know, is the damper stroking fully open and fully closed? Is it stuck? Is it fully open? Is it fully closed? What's going on with that damper? And then after we confirm that it's operating, we want to confirm that the actual airflow is proper based on your airflow measurement station and against BAS. And you want to do that with the TAB. Again, as Justin talked about, you want to definitely confirm sensor calibrations. One thing that we'll talk about in the COVID mitigation is RH sensors and how they can kind of help us with this COVID. So definitely confirm the temp, and if there's RH sensors installed, confirm the calibration on both of those. And then what do the filters look like that are currently installed? You know, how often are they changing them? Are they MERV 8s? You know, do we have blank offs installed in the air handling units? Do we have any gaps around the filters? You know, are we actually going through the filters? Those are really important things that we need to take a look at. And then after the physical equipment assessment, I like to go to a BAS assessment where we kind of review what's going on the control side. You know, Wade talked about the occupancy schedule. Is there an occupancy schedule? Is it set up? And if it is set up, does it actually match the occupancy that's of the building? So, I mean, these are simplistic things, you know, when you say them out loud, but at the same time, they're very important to set up, and it's amazing how many are not. So I definitely want to get that squared up first. And the second thing is you want to look at your OA set points. Now, after you've confirmed the airflow measurement station on the outside air is calibrated, now we want to take a look at the outside air set points. Do they match design outside air values? You know, has it been overwritten to 100%, or does somebody just overwrote the outside air damper period and it's not stroking at all? And then one of the other things that we want to look at is DCV implementation. So if currently the building is utilizing DCV, we would consider disabling that so that we don't bring less outside air in when the building is occupied. I know some of the questions are going to come up regarding energy cost versus COVID mitigations. So we'll hopefully address that in a little bit, but this is definitely one of those things that I do believe will definitely help when it comes to that. So we want to bring in the outside air. We want to have air changes going on through the building. So DCV implementation, and then some other things too to consider, depending on where you live in the country, is a supplier temperature reset implementation. A lot of times we reset the supplier temperature, but another option could be, Wade and I discussed this, increasing your outside air instead of, backing down on your chill water type. So that's another control strategy that you could possibly take. Next slide, please. So after you kind of do the on-site assessment and what I'm calling the health and wellness, then you're going to move over to, what can we do to the building? And of course, the first thing is going to be trying to upgrade filters. And again, making sure that we can fit the filters in there. Of course, one of the consequences of upgrading filters could be not having enough static pressure. So we'd have to evaluate that and make sure, but definitely minimum MERV 13. Research has shown that if we upgrade to MERV 13, as Wade said, COVID is a sticky virus, and we do want it to stick to different particles that are within the air and catch on that MERV 13. One of the other things that we'll talk about probably in the Q&A is when we change these filters now. Typically it's a quarterly type effort. But we might want to look at changing these a little bit sooner. And the other thing is we do want to look at monitoring the differential across these filters if it's not already implemented. That could be just a visual magnehelic or putting actually in a DPT or DPS. Another strategy would be implement pre and post occupancy flushes. So what we mean by that is before the building's set to be occupied, say 8 o'clock in the morning, at 2 hours before that, so 6 a.m., we want to turn that building to occupancy, so the outside air is actually circulating within the building. And then we want to do that post occupancy. So if they leave at 5 or they leave at 6, run that still for another 2 hours to continue trying to flush that building out. It's a fairly easy, low cost, no cost type change that can occur. The third thing that we could look at is controlling the space between 40 and 60% RH. So research again has shown that if you maintain your building between 40 and 60% RH, the virus doesn't like that very much. So if you're in colder climates, you might have to look at putting in humidifiers. Warmer climates, we're doing pretty well at be able to maintain that RH, but definitely try to keep it between 40 and 60, and ideally even 50 and 60% RH. It definitely does good with that. So one of the things that you might have to do is install RH sensors, get those wired and calibrated and stuff like that. That could be another mitigation. And then lastly, that I kind of want to talk about is additional technologies. There's a few out there that we could utilize, but they have to be utilized the correct way. So I would definitely recommend you reaching out to your local engineer or commissioning provider to try to help you install, whether you try UV or other technologies, where you install this UV at, and so on and so forth. I think Wade will probably talk about that a little bit in the Q&A, because I'm sure it's going to come up. But you want to make sure that it gets installed properly to where it will actually work. The thing about installing them in air handling units is our velocity is pretty quick through that unit, and sometimes it doesn't get all of the exposure time that it would need to that particular UV. So they just definitely need to think about how they're installed and how many you have, and then also don't use UVA or B, definitely go with UVC. And I believe that's it for me. So I'm going to go ahead and turn it over to James.
Great. Thank you, Eric. Greetings from the swamp of the greater DC area. And Eric, you just mentioned RH. I just checked our hygrometer, and our office is at 71% right now, which means our building is probably struggling with fresh air management as they try to get ready for folks to reoccupy. Next slide, please. So just for some quick background, I have none of the credentials of my panelist colleagues. We do research in the real estate space, and part of what I'm going to talk about is a study that we conducted in April and May, which basically will just give you a little bit of insight into what occupancy in the future might look like, since all three my colleagues mentioned that as part of the factor that you have to deal with. The study we did actually dealt with the office tenant decision makers from the C-suite on down through the organization to just try to get some insight early on in the COVID crisis as to what people were thinking. Next slide, please. So the major takeaway from our study, and this was nearly 400 people. It was a regional study. It was Pennsylvania down to North Carolina, so it was a mid-Atlantic region. I should mention that we are currently, as of next Monday, actually launching a national version of this. But, the major takeaway was that people at that time, 62%, were seeing less value in the physical space as people migrated to obviously having to close their offices, go to remote work strategies. Firms that had perhaps traditionally been resistant to that found all of a sudden that they were able to cope. And that will be a factor in the new normal. Next slide. If you think about generally the trend, because the theme of this webinar obviously is sort of looking into the future and how the new future will be different than the old future. Some of that is, if you think about the trend in the last decade, it's all been about the move towards greater density, more employees per square foot, greater amenitization and sort of live, work, play elements, the density of retail in office buildings, buttressed up against residential and neighborhoods. So really we were creating these pods or communities. Obviously what COVID done is it hit a big sort of Control-Alt-Delete on all of that and given people some pause on that. Obviously there's some safety concerns. And as we've seen with, the up and down of the COVID cases and how it's changed from certain hotspots to new hotspots, including states represented by some of the folks here. But really the biggest thing we were trying to understand was what would people be thinking about kind of going forward. And I won't go into too much detail, but really what we're thinking or what we're seeing is that people are going to be making changes to their offices as they come back to work. To the extent they can work within their existing footprint, They would go away from, you know, more open floor plans where you had desks kind of, you know, buttressed up right against each other. Obviously getting some social distance spacing, that'll have an impact on some of the issues that were discussed before. Obviously the staggering of workforces. So when you're looking at your occupancy schedules, really it's kind of all over the map. And obviously this was a very early read on it. But I think that even in 4 months, the questions guiding the future are really no more certain. You know, we're really not that much closer to a vaccine. Obviously, you know, summer has been more disruptive than perhaps people thought. And now we're moving into the fall and moving into the regular flu season. And obviously from workforce management or HR policy, you have folks all around the country who are dealing with a patchwork, one size does not fit all approach to going back to school. And we were talking just before this call about, you know, some schools going all online, others doing staggered schedules. All of these things have impact on the office. Next slide. So the big point of view as far as reopening is really people feeling safe. And you guys obviously play a part in that. It's sort of the, if we build it or if we make the air safer, will they come? You know, that is a tall task because obviously some of this is in your hands, property management. Obviously, the employers have, you know, different strategies that they have to consider, whether it's, you know, full mask wearing inside, how disruptive can that be to a work day? Excuse me. Again, staggering of schedules, alternating, you know, different times and, you know, how you can use the break rooms or the kitchens. You know, all these things that we've come to rely on in recent years is one of the benefits of being in the office, the co-working space, everything from, you know, what you hear as far as, you know, foosball tables or, you know, romper rooms where people do brainstorming and whiteboarding. A lot of that stuff now goes out the window in the new office. So major design changes, and again, I'm sure that many of the folks who are participating in today's call will be a part of those discussions. But we are, as I said, going in to do 3 more of these studies because we're going to have a longitudinal look at this. So we'll have some information at the end on how you can keep track of those. We'll have results from the next study at the probably the beginning of September, which may give you some insight into the current thinking. But, you know, the major takeaway for us is that, you know, with more than 60% of, you know, decision makers in office space rethinking from a variety of different angles, that's a very significant number. You know, again, the trend in real estate has been more of a follow the herd of move towards density, move towards more amenitization and shared space, co-working, things like that. And now people are rethinking that, whether it is that they need less space or they need better utilization of their current space. There's going to be a lot of disruption as far as how that impacts the occupancy schedules. And of course, it's not one size fits all. One of the things that was in our study, and I don't have the slide here, but you can get the full presentation. This obviously varies by industry, you know, whether you're a professional services firm, an educational institution, high-tech firm, all of these folks have had different levels of success with remote work. Obviously, they'll have, you know, different needs as far as bringing certain functions back to the office sooner, where perhaps it wasn't working. But it's not going to be a one-size-fits-all. We're going to be laying the track somewhat in front of us. But, you know, obviously HVAC and, you know, all of the air quality measures are going to be a major part of giving people some level of assurance because it's not just about, you know, putting stickers up about where people should stand or limiting people on elevators, but those are certainly part of it. It's generally going to be, do people feel safe? So with that, I'll stop my comments, and I guess we can switch over to Q&A.
Thanks, James. Can you get the next slide? Thank you. Okay, so hopefully to continue with the Q&A and then open it up to some discussion. Let me feed you the first question that's coming in. What is the committee's opinion on ionization?
Right out of the gate, huh, Sam? So that's an interesting one. And the ASHRAE's epidemic task force has looked at that, the disinfection and filtration and disinfection team. We actually consulted with CDC on this. I have actually had new, and I say it was coming up, but from a standpoint, there is not necessarily a method of test for ionization for checking its performance from one manufacturer to another. The one item that is critical is it's a UL 2988, or which is the one that confirms that certification says that they do not produce ozone. CDC indicated that they still felt that the needlepoint type was an emerging technology, and that people needed to consult with engineers and others for its application, the way it's been studied or looked at by the manufacturer, and the actual use that you're going to be using it in, and making sure that those studies actually align with that application. That's where CDC came back on bipolar ionization. So that, when you say the panel, the task force, that's the line I have to take for that. Other panelists may have a personal position on that, but I've commissioned them, we've used them. I'm not saying that they do not work. I'm saying is you need to have the appropriate one and the appropriate application to it. So I don't know if Eric or Justin have a take.
Yeah, I mean, I'll touch base on it, I guess, real quick. I think Wade knows where I stand with this. As TLC, I don't think we're specifically recommending these currently, as there's not enough evidence and research from us, from third-party testers, saying that they do actually provide assistance with mitigation of the COVID. So a similar stance with Wade. If an owner is dead bent on it, then we'll pursue it. But we typically take different measures before implementing that one.
Well, the next question coming in, maybe Justin can head this one off. What type of maintenance safety procedures should a maintenance staff follow in this era of COVID with respect to air handling unit cleansing and filter replacements?
I think Wade talked about it earlier, and so did Eric as well. I think the key to it's going to be, in the past we've used more rigid schedules from a standpoint of doing PMs and filter changeouts, which is a part of normal preventive maintenance on these systems. And I think moving forward, it's going to have to be a strategic and application-based program. So we're going to have to evaluate all the things that Eric mentioned, really looking at, and even James touched on some of these trends moving forward. We're going to have to look at, how are we using the spaces that are served by this equipment? So what is the, what can we expect there from a standpoint of potential contamination, and things like that, where we need to, obviously, if it's still a high density area and we can't do anything about that. It's a space that has to operate, and it's always going to be exposed. Even if you're doing multiple shifts or things like that. Obviously, that type of space is probably going to warrant more frequent PMs and disinfecting measures. And there's a lot of technologies out there, and emerging technologies for that matter, that can help with that. I think it's far more than we can talk about today. But I think the key to it is we've got to look at the applications. What, if it's a very low density, space and it's an air handling unit serving, say, series fan powered boxes in an office space, you have, you got a lot of probably dilution there. You got a lot of, you're just not doing tremendous air changes back through the air handling unit itself, right? And so from that standpoint, you may do less than obviously a more dense area. So hopefully that helps.
I think if I understood the question, Justin, I think you touched on some of it, but I think some of it was more on the maintenance side of it, maybe, and that's the proper PPE. It's in the ASHRAE's filtration and disinfection. It differs if you've got known COVID. So for like healthcare, it gets to a different level. You could consider throwing hairspray or spray paint or something on top of the surface of the filter before you remove them, just from a standpoint of trying to keep things held there. But wipe down before you get there. Glove, mask, face shield from the standpoint. And some of that gets back into what Justin is saying is what's the likelihood of that. And so you build that threshold, and regardless, healthcare application, you're going to be doing those things. Remove them, make sure you're wiping down, put the new filters in, make sure they're sealed very tightly, that kind of thing. So I think between that kind of answers the question, depending on how it's interpreted.
Thanks, Wade.
I have another one coming in about energy use. All these recommendations seem to lead toward using more energy to fight the virus. What do we do with the requirements of energy codes?
So that's a really interesting one. Occasionally we always kind of, ASHRAE 90.1 is the federal energy code, but every state has, whether they have adopted or they've gotten their own. One of the things is most people are operating buildings, for keeping people comfortable and using the least energy possible, right? When you look at, higher education, you have a lot of different types of facilities, which include health and medical, which are built to keep people safe and then keep them comfortable and then save energy or use the least amount possible, or laboratory spaces, whether it's research or it's student laboratories. And so what's interesting is that we're taking a lot of facilities that were not built with safety as its utmost priority in terms of that hierarchy, right? Safety is still a piece of it, having the right indoor environmental quality, right? If you follow standard 62 and meet standard 55, you're providing a good indoor environmental quality. But I think we can all agree that a dorm room or a classroom building is much different than a BSL-3 lab in terms of the design for safety. And so it becomes that, and Eric mentioned it a little bit, it's a safety benefit analysis that you have to do for your specific facility, for your specific building use, occupancy level, and where you're located, right? Are you in a hotspot or not a hotspot? That may change some of the things that you're about to do. But when you put safety first, energy follows. And so well aware of that, and that's why when Eric mentioned the instead of using like a dynamic supplier temperature reset, where if your building comfort is satisfied and the relative humidity is good, and you go ahead and reduce your chilled water, well, now increasing the amount of outside air, you're not increasing the energy to get that outside air than what you would have been doing before. You are going to use more than using supply temperature reset, but that becomes that piece to it, right? We know of facilities that are continuing to say we're going to operate 24/7, even though ASHRAE has come out and shown the science of three changes of air, of outside air into the building of a well-mixed space will reduce contaminants by 95%. That's where the 2-hour pre and post flush, if you don't do those calculations, come into play, is a lot less energy than running it 24/7. And in April, there was an article that came out by an individual who is an ASHRAE member, but it was his opinion, and it stated run it 24/7, and people are still clinging on to that. So we're cognizant of the fact that we're trying to reduce energy. Some of these sensor calibrations that Justin and Eric touched on, if you're cooling, a degree or two colder and you get it in calibration, that may actually save some of your energy. When you do the filter analysis, you need to look at the initial pressure drop. It may be a little bit higher than a clean filter of a MERV 8, but if you're only ramping up to that dirty level, you're not using as much additional horsepower as you might think. So, but that becomes down to the individual building owner's safety benefit analysis of where they want to operate. So, not sure if anyone else wants to touch that one or not.
Yeah, I mean, I'm pretty much in agreement with Wade. You know, a couple other items that you got to think about too is, of course, you know, we don't want to cause any additional money that facilities have to pay for. But the reality of it is during this current situation that we're in, you know, before we receive any type of vaccine, there's going to be an increased cost, and one of them would be filters. And you know, if you start looking at those filters, they could, you know, 30 up and say a month instead of 3 months, or a month instead of 4 months. And we're talking, you know, say facilities have a MERV 8 filter and they're going from a MERV 13. You know, that could be double cost of each filter, or even more, depending on the filter type that you use too. So, you know, I just want everybody to be aware that, I mean, there will be additional costs incurred, you know, to keep people safe. And that's what we're trying to do right now. Like Wade said, the laboratory spaces have been doing that. You know, energy is last, but we're having to flip-flop that on the office spaces to where safety's first, and now energy is going to lag. I don't think this, you know, me personally, I don't think this is going to be a permanent type scenario. You know, hopefully we'll be able to get a vaccine and this will, you know, clear out. But I do think we'll have to, you know, all the municipalities and stuff, we'll have to relook at different energy saving ways that we're doing and how that's going to impact us moving forward.
You know, on the subject of costs, that probably seeps in pretty seamlessly to our next question. Maybe everyone has input, or maybe James came across something relevant in his research. How do you balance physical spaces as it relates to limited financial resources, such as restructuring an open office plan or installing cubicles and other barriers? Is it just a given that we have to accept these extra financial resources, or are there other creative ways that we can take on COVID-19?
Well, I can start, and that certainly goes to the complexity of this. You know, the first bullet that I showed you was really driven by 60% or more of decision makers who are sitting there rethinking the ROI that they're getting from their physical space. Why am I spending $40 a foot when half of my employees are not even coming to work, or I can't bring them back safely? So they start there. We obviously did this study on behalf of building owners and property managers who are looking at the other side, which is what Eric and others have mentioned, which is part of that safety ROI equation that you have to do. That, you know, for every dollar invested, whether it's in new systems, retrofitting, filters, whatever, who is paying for that? And ultimately, you know, what is the percent increase of safety that I can really, you know, how do you quantify that? Because some of this comes down to who is going to pay for it. And one of the things that we'll be including in the next study is some of the, you know, how much of the cost are tenants willing to take on through OpEx or, you know, other, you know, different fee equations. Because, you know, Eric, you touched on it, you know, is this a temporary blip, or is this really the new normal? And hope, unfortunately, is not a strategy. We're all kind of guessing and listening to Fauci and Birx and others, CDC, on we might have a vaccine by November. It might be, you know, Q1 2021. We're in unprecedented territory as far as, you know, the last great vaccine was done in 4 years. We're talking about turning one around in basically 9 months. So this might be a little bit of a, you know, bit of wishful thinking, but cost really does have a big impact on it. And obviously, to the previous question about energy management costs just writ large, as a game of whack-a-mole of, you know, you fix this, but then that increases as a result, and everybody's going to be concerned about it. And that's going to be driving a lot of the equation of, you know, renewal strategies for a lot of folks who are in that situation in the next, 6-18 months.
Thanks, James. So there were quite a few questions that came in about UVC, so I'd like to read off two back-to-back here. UVC has been discussed, but how proven is that technology when used widespread? And with coughs and sneezes traveling about 6 to 10 feet, have there been studies showing the likelihood of the virus staying airborne long enough to get through the ductwork and back to the filters and/or UV?
I'm going to start with the second one first, and I'll let Eric talk more about UVC. I believe in it, and TB, it's where it got generated. But the second one, a lot of people are paying attention. There's over 230 scientists that have been petitioning the World Health Organization to consider it airborne. And when you're looking at some of these individuals, they are IAQ, hygienists, specialists in that nature. And so there's a lot of research that pushes to that. And so a lot of people look at it first as in the room, is it airborne, is it moving around? The Guangzhou restaurant shows that, the South Korea call center shows that, the Skagit Valley choir rehearsal shows that within the room, and the air distribution and ventilation and filtration can impact. University of Oregon, and I believe it was the Institute of Health, did a study. It's the ID of SARS-CoV-2 on HVAC systems. And up to this point, it's the first study I've seen of it. They actually looked between the return diffuser and return grill and the supply diffuser. Most of the studies that you had seen prior to that, in terms of the distancing, they were looking at materials, surfaces within the space and seeing how far it could go, 18, 20 feet, et cetera. So what this study did is it was actually an active hospital. And so they were taking sample readings from 9 different locations in the air handling unit. 3 on the mixing box side, or leaving the mixing box, 3 before the final filters, and 3 after the final filters. So 9 reading locations. 25% of their readings showed RNA of SARS-CoV-2 in the system. That's after a MERV 15 filter set. So there was some past those filters. So from that standpoint, the fact that the RNA was present shows that it is being airborne long enough and aerosolized and et cetera. You start to talk to some of those individuals and they fight over what those 2 words mean. But in essence, it's getting into the HVAC system. Their next phase, they are going to look at the virality of that RNA. They weren't prepared for it at that point in time. But from that standpoint, we do know that in the space, the HVAC system is impacting it. And we also now know that within the HVAC system, it is being observed. And going back to your first question with the UVC is, it was proven through TB to kill the virus, and there's a lot of data and research in terms of UVC being very effective at killing the virus, at different viruses. But I'll let Eric or Justin dive more into that one.
Yeah, thanks, Wade. Appreciate that, man. So yeah, UVC definitely, I think it's been proven to kill it. The question is how long does it need to be exposed to UV, specifically UVC? And there's been different studies out there. I've seen studies anywhere from 2 seconds to 30 seconds, and it's still a little, in my opinion. I do think so. So backing up some, UV lights definitely help in air handling. We've been using UV lights for a while to clean coils and keep them clean and stuff. So I think implementation of UV lights in an air handling unit is definitely worthwhile. But specifically UVC to accommodate or mitigate COVID, again, has to be implemented in the correct way. And some of those ways, there's different technologies out there. I think they have upward emitting UVCs that you can place in spaces. But again, how do you get the COVID over to those spaces? And then you talk about implementing them into air handling units. Do the particles have long enough? Do they have a long enough time of exposure to UVC with the current, HVAC designs at, 300, 400, 500 feet per second across the coils? And then how many UVC lights do we would need in those spaces to try to, you know, trap as many as we can within the different particles. So there's definitely a big discussion there in regards to UVC for sure, in my opinion. And I think there's definitely research out there, and I just think it needs to be. I don't know if I've figured out a good way to implement it in the air handling unit yet.
It's there. It's lamp intensity versus exposure time. 500 feet per minute. You're looking depending on your intensity, you can adjust it down. And that's for a lot of people keep calling it wanting single pass kill, but you can have less than single pass kill. A lot of these other technologies are relying on, you know, 10, 20, 30 minutes to actually, go through air changes to do that. So, but your lamp intensity and the exposure time tells you how much it's going to do. So. Any other questions, Sam?
Oh, so we've had actually a couple questions about this. So let me read out one of these ones. If a building is 25% occupied in this new normal, are the ASHRAE guidelines values for minimum/maximum airflow rates at the VAV boxes no longer applicable? Are we, by virtue of reduced occupancy, gaining a higher ventilation rate?
Yes, in essence, you are. Right, the ventilation procedure deals with an area component which doesn't change, and then people component. And when you look at the list of the mitigation strategies, increased outside air ventilation is key for the occupant. But and so meeting your design, the normal design occupancy gets you a value. If you have less occupancy, you'd have more outside air per person. But keep into account this outside air is helping you with flushing. And so by that number not necessarily changing, you're flushing it at the same time frame that you would be. And a typical office building, like we said, is to achieve that 3 air changes per hour, 3 air changes, excuse me, to get the 95% contaminant removal, you're still looking at 3 or 4 hours. So if you cut it back and reduced it, your pre and post flush would have to be adjusted as well. So I would take that as an account of I've got increased outside ventilation per person in the space, not necessarily for flushing it in the pre and post. I hope that answers their question.
So I hate to cut us off because it's such good conversation going on, but we are at the top of the hour. So I have to close things out by thanking Justin, Wade, Eric, and James for being with us today. Also to APA for letting us have this platform to connect with everyone. I do just want to do a quick shout out. You might have noticed that one of our panelists, Eric, is a certified energy management professional. EMA administers this ANSI and Do Better Buildings Workforce Recognized certification that incorporates a commissioning-based approach to energy management. If you're at all interested, please feel free to reach out to me. My email's on the left there, same with all the panelists. Or you can visit us directly at energymanagementmgmt.org. Billy, I'm going to hand it off to you.
I want to thank Sam and Ed, James, Justin, Eric, and Wade for their contributions to this excellent webinar today. I'm getting great feedback and comments in my email. And I'd just like to say thank you so much. And until next time, be safe and stay healthy. Bye-bye now.
Thanks.